My name is Jim Murungi Gitonga from the Department of Medical Engineering. I finished my 5th year. I realized most of the people are being misdiagnosed with pneumonia. So I decided and I looked and checked because the patient would go, they will be told of a different disease. They go today, they be told of a different disease. Tomorrow, they of a different disease, of which pneumonia can be confused with other chest diseases, which are 14. So it simply means with that, the doctor might be biased. All the eye problems, they might misdiagnose the disease of the patient. And now from that point, I realize now we need to include and incorporate machine learning. Machine learning or deep learning is whereby you train the computer, you give it instructions such that if it gets an image that has got those possibilities of what you are looking for, it gives it a 1. If it doesn't, it gives it a 0. But now that 1 is between 1, it's in terms of 0 to 100%. If it's so intense, it will be 1. If it is in between, it will give it a certain probability of 0 point something. Now, from that point, now after I realized that, I correcting data from the cargo, which is the FDA in America. Then from that point, the data set, I trained it. It took like 2 days to complete the training and validation, and I tested all of it. And then from that point, I got the model of what I was working for. Now, what do I mean by that model that I got from the data? The model was simply this, the equivalent of it, of that training, the average of everything, such that now the computer could be able to identify which image has pneumonia and which image doesn't have pneumonia. And all of this, remember, I'm using machine learning, which is the algorithms that in between it. Now, from that point, the model that I got from it, I built a software. From it now, I used to build it a software. Now, the software that I built, it's just like getting that model, cross-checking using it. If it gets any image that has pneumonia, one of the things it will do is it will do the heat map to an image. Like it will tell if an image has pneumonia. And then on the part of the heat map, it will be able to help the doctor in this way. If because the computer will be able to tell the doctor, I have classified this image as pneumonia because of 1, 2, 3. Are you getting the point? Now, then again, it will be able to tell the doctor, check position A, check position B, check position C. Now, and those positions, all of them, you will see there is yellow part and the heat maps on it. And that's what all of it. And now from that, I built the software of it now. And now the software is running, it can be able to detect the pneumonia. Now, the software works this way. There is the login, whereby the doctor will need to log in into the system. After they log in into the system, then they will be met by patient details. They will need to key the patient details such as surname, age, locality, phone number, then the gender. Now, from that point, after let us enter the details. After that, they'll need to save those details. Now, from that point, what they'll need to go to the next step. And the next step is now to get the image that has been taken by the CT machine, which is a computer tomography or the X-ray machine. Now, that image, they just pick the images that have been, and then those images, they need to, after they select them, we need to go and select. We are selecting the images. Then, when they select the image will be processed. And when it will be processed, then there will be now the outcomes or the probability of. Like here, my image shows me, my image has got a probability of like around 90.4% pneumonia. Now, and then it has got a normal, then it has, the normal is 0.09. So the highest probability here is pneumonia. So this shows this image as pneumonia. And on this part, this image can be saved, which now is, when you save it, you can rename it again. Then the doctor might ask, why has the computer to send this image is a pneumonia? You know why? Why? You know, those are the question why. Now, they need to run the cross-check now to validate using the other part of the heat maps, of which now we need to run them and check why did the computer classify it as a pneumonia, why did it classify it as normal. And with that, we'll need to see, there is a folder here, I'll get it. Now from that, I'm running the program. Now, when the program is ran, one of the things you'll note on the images is simply this, that when you check at all those images that are being generated, because it will generate all the images that will be generated, you'll check and see where the computer targeted when it was classifying images, this and this as pneumonia, image this and this as this and this, image this and this as this and this. And now it is showing me the results of the analysis. It's a blue, red color, white is the where the intensity of the colors are. And now from that point, the doctor can make a decision if this patient has pneumonia or no pneumonia. Now from that point, then we can go to the other part of the web-based. For example, the doctor might not be having an accessory of a computer, but they need to have a mobile phone. Now, for example, this one can be hosted on a server where the doctor needs to run it and get they just need to go to the link that I've created. From that link, they can get the image. Let's go to that point. The images of the patients. Now, my server is on. The website is on. It's already powered. If I share the link with you, you can be able to access the website right now. Now, I need to get the image. Now, I process the image over the web. It is showing me now the image is at 0.95% of the pneumonia. So the image is infected. Now you see the machine learning can tell the doctor even to the extent. That percentage shows this, the extent the disease has gone. Then to the incoming innovators, I want to say this. University teaches, students, the people in the university innovates. God bless you.